Oh, good evening, Vishnu sir. Hello. Good evening, Vishnu sir. Can we start the session? Hello. Yes, sir. Can we start the session, sir?
Hello, do I audible?
Hello. Yes, sir. Good evening, sir. Sir, can we start the session? Sorry, sir, you're not audible to me.
Do I audible now? Hello.
Yes, sir. Yes, sir.
Yeah, sure. So can I share my screen?
Yes.
Hello.
Hello. Yes, sir.
Yeah, can I share my screen? Can I share my screen now?
Yes, sir. You can share your screen.
Yeah, sure.
Oh, hello, Vishnu sir.
Yeah, good evening. Good evening, everyone.
Can I give you a little introduction before starting your screen?
Sure, sure.
Yes, sir. Good evening, everyone. We are about to hear from someone who truly represents the spirit of innovation, curiosity, and leadership in the world of mobility and aerospace. Let me introduce you to Vishnu Prakash sir, an automotive and aerospace professional who is passionate about bridging the gap between cutting edge research and real world applications. Currently, he wears two exciting hats as the project manager at Aerospace Tech Private Limited, where he leads R&D initiatives in aerospace technology, and as the Chief Operation Officer at Aeroin EduTech, where he designs and delivers training programs that make futuristic technologies accessible to schools, colleges, and institutions across the country. Armed with a bachelor's in automotive engineering and hands-on experience in both aerospace and electric vehicles, Vishnu Prakash sir specializes in areas like battery pack design, EMS, propulsion systems, thermal management, autonomous navigation technologies like LiDAR and cameras, as well as drone and satellite applications. Beyond his technical expertise, what truly sets him apart is his vision to create a global hub of innovation, one where education and technology blend seamlessly to inspire the next generation of engineers and change makers. His professional journey is filled with achievements from redesigning starter motors to improve efficiency at Comstar Automotive Technologies, to contributing to EV power electronics, to authoring more than 16 research papers in automotive, aerospace, and embedded systems. Not only that, but he has also been a mentor, leader, and trainer, building technical teams and guiding students and professionals alike transform classroom learning into real-world impact. Today, he will take us into one of the most exciting and fast-evolving areas in mobility, autonomous cars with his talks on LiDAR versus camera versus radar tech battle for autonomous cars. He will walk us through how autonomous vehicles perceive their environment, explore case studies from leaders like Tesla, Waymo, and Mercedes, and give us a glimpse into the future of sensor fusion and AI-driven mobility. So, without further ado, I would like to hand over the dais to Mr. Vishnu Prakash sir. Thank you.
Thanks a lot. Thanks a lot. So, by the way, before starting the session, I really thank ISA India Career, Charging Career for giving this opportunity. So, good evening, everyone. So my name is Vishnu. So as he said before, I'm working as a project manager in Narayan Space Sugar Limited, and I'm good in EVs and other stuff which is related to the autonomous vehicle as well as in multiple sectors. So before going to topic, I'd like to have this session as a little interactive. Okay, so I may interact with everyone in between, and I may ask some questions. So I would like to have a little bit interactive in this session. Okay, so let me jump into topic. So first, what is autonomous vehicle and why we need? So actually, the topic which we are talking today, actually, it's the most debated topic in automotive industry because here we'll be understanding which sensor dominates each other in autonomous vehicle because these three are playing a major role. For example, Tesla is saying that cameras are enough to run their autonomous vehicle. As Waymo say that, I mean, the Google Waymo say that lidar as the are the most important thing in an autonomous vehicle because without lidar we can't able to do anything as well as the radar. It is meanwhile it is quickly dominating the ADAS system. I mean the total ADAS which is growing now. So I hope these three are a little tough battle to handle. I mean to see its positive as well as in I mean the negative on all these things. So today we'll see about each and every pros and cons of each sensors as well as they're working and how we can able to utilize in upcoming futures and what are the future possibilities are there and everything. So let me get into the topic. So these are the agenda today we are going to see. Okay. So first thing we'll see about why we need the sensors as well as the each and every pros and cons of each lidar, camera, radar as well as the for the things. And we'll see the global comparison, like what are the industries and their strategies, as well as the future outlook, like how it's going to become, and what is the context in Indian market and technology status, and what are the Indian companies are working with this, and the case studies, as well as the abilities in India and the market insight and future outlook of India. Okay, so these are the things which we are going to see today. So let me start from the first thing. Before getting to the topic, why we need sensors in autonomous car? Why we need a sensor? What is the purpose of having these lidar, camera, as well as radar? Any answers from your side? Like anyone? Why we need these things? Anybody is willing to answer? So fine, not an issue. Let me start. So basically, if something is getting into autonomous, for example, if some object is converting into unmanned category, so we need some peripherals to observe. For example, we are a human being, so we have ears, eyes, as well as nose, as well as sensitivity in skin, and all these things. So these are our input organs and input devices, which is giving some data to us. As well as we have a processor, which is called brain. As well as we have some actuators in our body, the muscles. Okay, so each thing are collaborating each other, and they are giving some values to us. According to us, we are processing it, and we are working according to that. Okay, the same thing for each and every object which is going to be I mean autonomous or automated. We need some sensors to get the details. So here the lidar plays a major role. Okay, so the lidar is giving some high resolution 3D models. For example, kind of some mapping data. I'll show what are these. So it will provide some 3D models surrounding of the, I mean 3D models of the surrounding. Okay, and the next thing is camera. As we know before, camera is it's an image sensor. Okay, so it will detect the image and it will capture the images. So based on the images, we can get some data. For example, the colors. Based on the colors, we can figure out the road signal, I mean road signs, some gestures, as well as multiple things. Okay, and then radar. So radar is slightly related to the lidar, but it is helping us to work in poor conditions. I mean the poor weather conditions and all these things, some kind of tough scenarios and all these things. Okay, so we have to rely on each three things uh, to to make it little bit safer in the atmosphere. So these are the three major sensors which you are using in autonomous vehicle to utilize it properly. Okay, so these three are input devices which is giving us the data about the surroundings to observe the surroundings. So in my perspective, these are the eyes of the autonomous car. Okay, so we are going to break down each three into with their strength and weakness. and then we'll see which is relying on the which is relying the most on all these things. So the first thing is lidar. Lidar is nothing but it's called light detection and ranging system. Okay, so it is uses some light beams, some laser beams. By using these laser beams, it is for example, in our school days we have studied about sonar. It will produce some sound waves. The sound waves will what is that, reflect on some object and will return back to the sensor. I mean, it will bounce back to the sensor. So based on that, we can we can calculate the time taken between the sense. I mean, the signal which is travel from the sensor to the object, and I mean there's a time taken between the sensor. I mean, sensor where the signal has been bounced back from an object and returned back. Okay, so by using these, this is called time of flight. So by using these calculations, we can able to measure the distance of the object from one place to another place. The same concept applies in lidar. Here we'll send some thousands of laser beams per second. So by using these laser beams, we can able to calculate each and everything which is surrounding to us, which is surrounded to us, and we can able to make an hologram of these things in a 3D, kind of a 3D hologram. So based on that, we can measure what are the objects are near to us, and what is the distance between here and there, and what's its shape, and we even if we have some multiple sensors into it, we can also measure the temperature and multiple things about these objects. Okay, these sensors are not only used in automotive frame. Even in my experience, I have used these kind of sensors in aerospace. So we'll be implementing these lidars and drones. By using these, we'll be mapping some areas. I hope a few of them have been known about drone mapping. So it's nothing but we'll be using a lidar there. We'll be flying a drone on some particular areas and particular space. So where it captures the surrounding, it totally maps the surrounding, like how the Google Google cars are going on the streets to map the whole street, like for the street view and all these things. Like that, these lidar will map the whole area into a hologram image. So by using this, we can able to observe like what are the objects are there, and how we can able to utilize these things. For example, in drone, if I will take the drone condition. In drone conditions, once we map the area, we'll be having some hologram image of the hologram image of the total area. So based on that, we'll be creating some route way, some route to pass through, kind of some patterns to pass from one place to another place or something. So we'll be generating some ways from that. So this is how lidar works in multiple fields. So here in automotive, it is used to measure the vehicles. I mean the surroundings. Okay. So let me show some models in it. So these are some models. These are some lidars which is used in current market. So basically, these lidars will have range around 200 to 300 meters, and I'm considering a model. So based on that, it is giving around 200 to 300 meters range. So the model is called Velodyne Prime. I mean Alpha Prime. So this is that model. So these things are used in some what is that? These things are in laboratory thing, like for these things are under research process. So they are using these kind of lidars in some autonomous vehicle to capture to run the bench models and all these things. So these things can able to send around 64 to 128 beams per millions of points per second. And there are three type of lidars are there. The one is mechanical lidar, another one is solid state lidar, and third one is flash lidar. So the mechanical lidar is nothing but it will be having a lidar in a spin wheel. It will be spinning in 360-degree. So based on that, we can able to calculate the whole surrounding in 360-degree. Okay. So it has some moving parts. For example, this is an 360-degree lidar. So here you can see the what is that, the lidar model here, and these total object will be spinning according to the condition. It will be spinning in certain rpm. So based on that, we can able to capture the whole 360-degree area of an object. Okay. And the next thing is solid state lidar. Solid state lidar is nothing but it will be fixed on some portion, like it doesn't have any moving particles or anything. So it will be fixed in some points. For example, it will be fixed in the car's grill. Especially if you're seeing some expensive cars, for example, the cars which is integrated with ADAS or something, you can spot the lidar directly, because it will be attached in the front of the vehicle. For example, in the grill, especially in the grill. Okay. So there they'll be using solid state lidars to operate it. And there is another one lidar which is called flash lidar. So these lidars will be used for will be placed in the top of the windshield. I mean, near to the rear view mirror. So these things will help us to measure some short range, but in a faster time period. Like these things will help us to what is that? Measure some kind of vehicles and some in some difficult conditions. And the next thing is same their strength. So these things are good in 3D mapping and excellent in depth perception. For example, this is the 3D hologram view of LiDAR. So this is how we'll be getting some output. So there is an software called software used for cloud mapping. So cloud mapping is nothing but we'll be getting some multiple data from these lidars, and we'll be collecting it, and we'll be combining it, and we'll be getting a image like this, a hologram like this. So that's called cloud mapping. So we'll be using these kind of multiple softwares and machine what is that AML platforms to generate these kind of images, and based on these images we'll be calculating some data. Okay, and these things will work in low light and night conditions. But the weakness is this is slightly expensive compared to the other sensors, and it may get affected by rain or fog or something, because due to the light scattering and all these things, and it's slightly bulky. As I said before, these solid state lidar will be slightly bigger in size, because I'll show some images. So there you can able to spot the lidar in a car. So these lidar will be placed in this part, like the front of the car. So it will be slightly bigger in size, but according to the size, their data will be they say like we can able to measure some short range. And their weakness in India, obviously in India we'll have some dust, fog, and some I mean heavy rains and all these things. So based on that, the beam may scatter, and as well as the cost limits, because lidar is slightly expensive, so we need to adapt properly for it. So these are the weakness which is there in India. And the next thing is, I mean, before going to the next thing, and there are a few things and their application. I mean, this application of lidars. So basically, these lidars are used in 3D mapping and localizations. For example, as I said before, the autonomous vehicle and all these things, as well as I gave some example where we are using in drones on multiple segments. So these help us to detect the obstacles and see some pedestrian whether they're crossing it properly or not. This is how the lidar maps and all these things, and this is how they get some real-time data about it. And these things are also used in some navigation complex area. For example, some roundabouts or so intersections or something, to measure the distance, to measure the roadway properly and all these things, and helping us in I mean parking as a system. But these are not utilized in normal cars, but these are utilized in heavy end cars, where we have 360-degree lidar support and all these things. And it is also used in some smart cities to manage the traffic conditions and all these things. Okay, so the next thing is camera. So obviously we know about camera. So it's an image sensing device where we can able to capture the image of surrounding, and based on that image we can able to get some data. Okay, so basically cameras are the eyes for the car. So these captures the real time images of each and everything which is being in the atmosphere. Unlike the lidar or some other sensors, these things can able to detect the colors and shape and details of the image. For example, it can able to uh, see the signboards, it can able to measure the colors of it. For example, the traffic signal colors and all these things. This can able to measure the road gestures, or else some other details which is provided on the roads to monitor. For example, the speed limit and all these things. So these cameras will be used in multiple scenarios, and the Tesla is depending more upon cameras rather than the lidar or radar. Okay, so the Tesla uses multiple cameras in their vehicle. So by using the what is that image recognition, they are running their autonomous vehicle. Okay, so if you look about camera, so camera basically use two type of things: the CMOS and CDDS sensors. So where these capture some RGB images. Sometimes we can also add some IR. So IR is nothing but like infrared. So these cameras will be having some what is it extra modules to operate in multiple conditions. For example, in daytime as well as in nighttime. So in nighttime we don't be having light, so the camera may get poor vision. So at the time we'll be using some IR sensors. So based on these IRs, we can also get some good image in nighttime, as well as some other data will be provided by these kind of IRs. So basically, the camera vision plus the AI which is processing the image and which is used for object recognition and all these things. And there is another one advantage type in this stereo cameras. Stereo camera is nothing but instead of having one camera, we'll be having two cameras. For example, you can see here. So we're having two cameras here. Like that, there are multiple types of cameras. I think. So I'll explain about these type of cameras and types. So before that, we'll see about other things. As I said before, the Tesla is fully vision based on the cameras and all these things. And these LiDARs are used for lane departure warning, as well as the traffic sign recognition and parking assist and all these things. So here you can see some the what is that deep learning image of a camera vision. So here you can see the details, what are these things captured and how it is utilizing into the data and all these things. And these cameras are separated in two different field of view. One is the narrow view, another one is the wide view. So the narrow view is nothing but it will be just focused on certain narrow angles. The wide view is nothing but it's slightly a wide length camera. So based on that, we can able to have some wider vision. And there are four different types. The different types are, first is monocular camera, which is where we are using single camera in a vehicle to a single camera in a part to measure something. And stereo camera means like we'll be having some left right cameras like as like a human eye. You can able to see here there are two cameras here. So these are stereo cameras. So by getting two different details, two different data from two different camera, we'll be combining it to each other. Based on that, we can able to get some wider view as well as some wider set of data, and then it'll be much precise than the monocular cameras. Okay. And the next thing is 360-degree cameras, like the surrounding view cameras. So where we'll be having some multiple cameras. Even nowadays we are having these kind of cameras in the vehicles where it is integrated with ADAS, and some vehicles are providing with 360-degree camera supports and all these things. So these cameras will be placed on each parts of the vehicle, and it will combine all the data into together, and it will give a 360-degree view of an object. Okay, from the surrounding objects. And the next thing is IR camera. IR camera is nothing but it's an infrared camera. So these cameras can able to utilize it in night, and it can also measure the temperature of an object on all these things. For example, it's kind of a thermal based camera. So in night times, even though the image is not clear, we can use these kind of IR as well as the thermal based cameras to detect the objects. You can see here, so the image can't able to find anything here. But by using this kind of thermal based or IR based camera, we can able to spot some living beings over here. Okay, so these are some examples where a normal camera is used as well as the IR based camera is used, and here also some images. So during and late daytime. So before going to these things, let me explain about the strength and weakness of this camera. So the strength is it is rich in semantic data, because it can able to provide the color, text, road markings, and all these things, and cheaper compared to the other sensors, as well as compact in design, as well as already produced as we seen before, because we are using camera in multiple devices. For example, in our laptops, in our mobile phones, in multiple devices. So it is having a greater strength, but the weakness are it will perform poor in low light area, as well as in some the glare time. I mean, while it is having some glare, or else in extreme poor weather conditions and all these things. For example, we can see in this image. So here we can see some glare of the sun. Okay. So based on this, we can able to get some image properly. So other than what we use, we'll be using some IR based camera. So based on that, by using these kind of IR based thing, we can able to get some data according to it. Okay. So the weakness are like it is not good in it is poor in low light area and glare and extreme conditions, and limited depth of perceptions, which means I mean in the monocular sensor, because as I said before, if you're using a single camera, their observing distance will be less compared to the stereotypes or other things. So these stereo cameras will improve the vision, but still the accuracy will be lesser than the lidar, because as lidar is having more range than the camera, so it is still less accurate than the lidar, and it requires huge AI training database and all these things, because even though we have the image, we need to have some AI and ML database to detect the objects according to it. Okay, so if it is not proper, the algorithm is not proper, the data is it's not proper, it can't able to measure it properly. It can't able to give some the proper data properly, because it need to detect the objects and all these things. So the database and as well as the AI training should be more proper. If the training is not good, if it is not trained well, it may perform poor in some conditions. For example, the weakness in India. So in weakness, obviously the sun and these things are common in, I mean, the weather conditions are common in India for degrading the performance. More than that, we have some different kind of traffic conditions. So these cameras should adapt these kind of things. For that, we need to provide some specific training to the database to work accordingly. So these are the weakness which is caused by the cameras and all this, and their applications. As I said before, these cameras are used for lane departure warning, as well as sign recognition, as well as, I mean, the traffic sign recognition, as well as the pedestrian detection, as well as emergency braking system, as well as used for parking assist and 360-degree cameras and all these things for operating in tight spaces and all these things. And driver monitoring system. Not only these cameras are used for to monitor the surrounding things, as well as these cameras are used in cabin to monitor the driver's conditions. Because if he is feeling drowsiness, or if he is feeling if it's not healthy while driving, these cameras will detect them and help us to give some data, or else it will give some feedback through the steering wheel, or else it will stop the vehicle in a roadside properly. So by this, we have some add-on safety features in camera-based vehicles. And as well as the Tesla autopilot mode is fully based on these cameras. So they are fully vision-based navigation system, which is used on the road conditions and all this. Because in their place, we don't have much complex in traffic and all these things. So there, the camera is more than sufficient to work properly. But though they have few more sensors, they can able to perform a little bit tougher task compared to the current thing. But still, I don't know why they are fully depending upon the camera thing and all this thing in Tesla. So the next thing is radar. Radar is nothing but radio detection and ranging system. So these radars will send some radio waves. For example, these radars will send in 24 gigahertz, or else in 77 gigahertz frequency. So these radars will send some waves in these kind of frequency based on the model, based on their vehicle categories and all these things. The gigahertz may vary according to that. So these sensors will be placed in multiple parts of the car. For example, the front, side, as well as the backwards. So based on these sensor will detect some objects which is near to us. These radars will work same like the ultrasonic sensor. So basically, for example, in day-to-day scenario, we have a reverse parking sensor in our cars. So reverse parking sensors and multiple things are integrated in our cars from 2016 and 15 range in normal mid-range cars, and some expensive cars have been brought these kind of features in early days itself. These reverse parking sensors are based on ultrasonic sensors. Okay, but nowadays these reverse parking sensors are converting into radars. So they are implementing radars than the ultrasonic sensors. The ultrasonic sensors are cheaper in price. Lidars are slightly expensive than the ultrasonic sensors, but still nowadays they are replacing these lidar than the ultrasonic sensor. The only reason is lidar can able to work in multiple scenarios. For example, if you're having a conventional reverse parking system, so your vehicle sensor may give some improper data if it is raining or something. Because I have experienced these kind of scenarios in my day-to-day life. If it is raining, or if there is any droplet in the sensors, which is, I mean, in the reverse parking sensor, the sensor, I mean, the radar may be inaccurate compared to the other things. But these lidar will work much precise than the ultrasonic sensor. That's why they are implementing the radar than the ultrasonic sensors in upcoming vehicles. And these radars are also integrated with cameras. Here you can see. So these radars, actually this is an radar, but integrated with cameras, stereo cameras. So this is how the industries are using now. So we'll see how they are using it. But before that, I'm just giving some idea about the radar. These radars will work in multiple based off the Doppler shift effect and time of measurement, the time of flight concept and all these things. So these things can able to measure the range of an object as well as the speed according to the velocity and all, according to the relative velocity and all these things, and angles. direction of movement and all these things. So based on these can able to measure the speed, angle, as well as the distance between one object to another object. And these radars can able to get some precise data compared to other what is that uh, lidar or radar. But the thing is, and the advantage thing is it can able to work in multiple tough conditions, because in lidar we had a complex that it can able to work in tough conditions, but in radar it can also work in tough conditions, for example in heavy rains as well as fog or dust and something. So this is the biggest advantages in radar. So radar, actually these radar will work in the recent range of 250 meters, approx 250 plus or minus 250 meters, and the resolution may be slightly poor compared with lidar and all these things, and their accuracy are good in 10 to 20 centimeter range, as well as their velocity are 0.1 meter per second in velocity. And these types, so there are around three type of radars utilizing in day-to-day life. The one first thing is short range radar. The short range radar are utilizing 24 gigahertz frequency, and these things are used to measure 0 to 30 meters distance from an object. For example, these radars are used in blind spot detection as well as parking assist, as I said before, for the reverse parking sensors and all these things. So these short range radars are utilized in that, and the mid-range radars are utilizing 77 gigahertz frequency, and they are utilized to measure 30 to 80 meters, which can able to measure the cross traffic alert and all these things, like for measuring the upcoming vehicles and all these things. And the long range radar is also utilizing the 77 gigahertz frequency, but it can able to measure some distance from 80 to 50 meters. These things are utilized in adaptive cruise control systems, as well as the collision avoiding system, as well as in some emergency brakes applications and all these things. Okay, so and the last fourth type, the important major type, 4D imaging radars. So these radars are under testing now. So as like the lidar, these radars also can able to produce some 3D hologram images to detect the shape, as well as to differentiate the object, the height and weight in higher resolution ratios and all these things. So these things are in bench models and going and testing now. So it may come in upcoming future years to work more than accurate than now. Okay. So and this the strength and weakness of lidar. So basic the strength are it works in all weather conditions, as I said before, in tough conditions and all these things, and it is good for velocity measurement based on the Doppler effect and all these things, and relatively cheap and rugged compared with other sensors. For example, the lidar as well as the camera, it's slightly cheaper than that, and the strength in India, the major thing, because as here we have multiple weather conditions, it work in multiple scenarios. For example, the monsoons, the dust storms and fog and extremely irrelevant conditions and all these things, and these things are already approved frequency in by BAS. So our BAS has been approved this kind of these 77 gigahertz frequency, as well as the 24 gigahertz frequency in India. So based on that, these sensors can able to utilize uh, efficiently. I mean, in its full efficient in India. And the weakness are these are slightly poor in object classifications, because their range are slightly shorter, and these can able to get more data compared to the lidar or camera. Their range are slightly less compared to these things, so their object detection classification may be slightly poor, and these things are lower in resolution. But here nowadays we are trying to get some 4D imaging radar concepts, where we can able to increase the accuracy as well as the resolution of the images and all these things. And these things are widely used in Mercedes, as well as the BMW, as well as Hyundai and all these things. And as well as we are also utilizing these radars in the Mahindra. So the famous vehicle which is running in, I mean, the famous vehicle which is the first fully ADAS car in India, the Mahindra XUV700. So these cars also implementing radars in it, and they're also working accordingly. And the radars applications. So as I said previously, these radars are used for adaptive cruise control. So you may have seen some multiple images, like multiple scenarios. So the vehicle will detect the ongoing vehicle speed, and based on that the current vehicle speed, I mean the present vehicle speed will be reduced according to that. It will try to match the same speed. So these things are will be happened by the support of radar, as well as the forward collision warning system, as well as the emergency braking system and spot detection systems, as well as the rear cross traffic alert, as well as the imaging radar. So these things are the applications of the radar. For example, in left side you can see this image. I don't know how many of them have noticed this. What is that? This indication in cars. I mean, which will be indicated in the side mirrors of a car. So these things are utilizing radars. So by these radars will detect the upcoming rear vehicles. So based on that, if for example if the vehicle is crossing here, or if they are uh, if there is any road cross section or something, the sensor will detect it and it will give some driver alert. So based on that, we can able to be caution and we can take some proper decisions. For example, it can kind of a blind spot detection sensor as well as a rear cross traffic alert system. So this is combined of both things, and this is how we are using in our day-to-day real-time scenarios. And the next thing is comparison. So here we have the comparison chart between the three components: lidar, camera, as well as the radar. So the range is between 200 to 300 meter, and here in camera it's around 100 to 250 meter, and in radar 250 plus meters, because it's slightly in upcoming future tech. We are also slightly improving the accuracy, I mean the range, and as well as the accuracy according to it, and the resolution. Resolution is also related to the accuracy. So the resolution is very high in lidar, as well as slightly higher in camera, and little bit medium, low to medium in radar. Depends upon the imaging systems. I mean the sensor systems and all these things, and weather robustness. So based on lidar, it's slightly poor according to the weather conditions. I mean the tough weather conditions, because as I said before, these things may the sound. I mean the laser beams may scatter according to the conditions. So these things are slightly poor in abnormal weather conditions. As well as the camera, we have multiple issues in camera, the glare effect, as well as poor in fog area, I mean where we have fog and all these things. But these things are good in radar, because it's excellent in radar, because it can able to work in multiple weather conditions and all these things. And according to the cost, the lidar is slightly higher than the two other components, and camera is slightly lower than these two, and radar is medium to each other, because it's not more high or more low compared to the models and all these things. And in object detection, the radar is good. It can able to measure the shape and size and distance and all these things. But in camera, it's slightly excellent than the radar, because we have some image over there. So based on that, we can able to see the schematic image, as well as the text which is present in the image, as well as colors and all these things. But in radar, it's weaker, because it can able to measure some basic shapes and speed only. We can able to measure more than that. The accuracy, excellent in radar, moderate in camera, as well as excellent for distance and velocity in radar. Okay. In industry use, we have multiple uses. Radar uses used in Google Demo, Cruise, as well as Aurora, and camera is fully utilized in Tesla, as well as the Mobileye. Mobileye is it's an brand who are supplying cameras and multiple sensors for Indian ADAS-based vehicles and all these things. For example, even the Mahindra is procuring materials from Mobileye and multiple companies, and it is also utilized in ADAS systems and radar. It is utilized in Mercedes, Audi, Volvo for their ADAS systems and all these things. Okay. So there is another one comparison chart. Here you can see the actual thing. So the frequency as well as the wavelength. So based on these things, you can able to have some comparison between the three things. Here we use ultraviolet. What is that? Categories, and here we use infrared and all these things, and microwave and radio waves categories. So based on that, you can see the frequency pulse, how it is traveling according to it. And here you can see the spatial coverage. So in camera, we'll be getting the X and Y axis, but in lidar, we can able to get the three axis X, Y, and Z. As well as in radar, we can able to get the X and Z axis, but not the Y. So this is how these sensors are good in coverage and all this, and they are strong point. As I said previously, they are good in color detection and high resolution images, and lidar is good in native 3D data, as well as the radar is good in multiple weather conditions and to monitor the speed of ongoing vehicle or something. Okay, so these are these things are work. Let me go to the next topic, and after that I'll be giving some conclusion about these sensors and which is better and which is good, and what our future mobility will be and all these things. So according to the global industries and future, so Teslas are using 8 cameras. So they are using 8 cameras alone in their vehicle, and based on that, they have some AI system in that. So based on this, the Tesla vehicle is working, and the Google Waymo is using multiple sensors. For example, the lidar, radar, as well as the camera for redundancy and all these things. So they use three models in the same vehicle, as well as the cruise, which is produced by General Motors, are used only lidar for their heavy approaches and all these things. And Mercedes, Audi, Volvo are using camera plus radar for their mainstream ADAS, as well as some startup companies, kind of the Luminar, Innoves, as well as Eva, are also reducing the lidar cost to $500 in the global market, because these are the companies which is producing lidars nowadays. They have started producing lidars in lesser cost, which can able to, as well as they are trying to produce in larger amount. So by that, the global cost will be slightly reduced comparatively, I mean, reduced according to the previous gen. And the future outlook, like in future outlook, the main perspective is like we are trying to have some sensor fusion here, because by using this kind of sensor fusion, so we get multiple data here. So based on these multiple data, we can able to get some higher resolution data and higher resolution what is that contents accordingly. So based on that, we can measure it much precise compared to the other things. So this is the concept where the global industries are trying to push. So they are trying to get into the sensor fusion in multiple cases. If even though if one sensor fails, so they can able to compensate with the other things and all these things. And they're also trying to implement an AI and edge computing. Like the Nvidia is also trying to get into it, and as well as the Tesla FSD and Qualcomm Snapdragon. So these things are trying to get get some, I mean, make the system slightly faster and advanced compared to the previous gen. And they're also coming into these RMS category to produce some proper equipments to measure it, as well as to work according to the data and to handle the data and all these things. The emerging tech are here, we, like as I said previously, we are trying to uh, introduce the 4D imaging radars in high-end vehicles and all these things. So where we can able to add the height measuring system, as well as the to increase the resolution of the radar imaging and all these things. And some event based camera where it can able to mimic like a human retina, and it can produce some faster, I mean, give some faster reaction compared to the present cameras. And in multiple things we are trying to have some hybrid things, like kind of a lidar plus camera. As I shown previously, we have lidar plus camera modules, so where we can able to work in multiple way, because even let me take this combo in real time scenario. I don't know how many of them having iPhones. I don't know. So if you're checking your iPhone, you'll be having a lidar sensor in your iPhone camera. For example, in 15, 16, I mean the Pro Max series and Pro series and all these things. So there you'll be having some lidar cameras. Not only in iPhones, in some higher end Android phones are also having lidar sensors in their phone. So based on these lidar, along with the imaging system of a camera, it can able to detect the objects. For example, if you're taking a photo in iPhone or else in high-end Android phones, you can able to these phones will detect your face, and it will detect some objects properly. While even if you're using some macro cameras or something, are there these lidar cameras will help us to measure and detect the image I mean detect the object properly, and by then the camera will focus the view according to that. So here we are utilizing radar in normal day-to-day phones. The same applies in autonomous vehicle. So where we can able to measure multiple objects and multiple things in day-to-day scenario. Based on that, the camera plus lidar will be making a ultimate combo to uh, measure much precise, because the camera will provide the data of the color as well as the signs and all these things. The lidar can able to provide the distance, and we can able to create some 3D image. So based on these two things, we can able to get some proper, I mean the proper high definition 3D hologram image of atmosphere. So based on that, if our AML is quite stronger compared to the previous thing. We can able to make the reaction much faster and much precise than the current generation. Okay, so this is how the companies are working and the global industries are working on. And if you take about Indian market, so in Indian market now we are getting into ADAS. I hope everyone know about ADAS, the adaptive driver assist system or advanced driver assist system, which is introduced now in India. So in previous gen we are there in around ADAS level 0 as well as in level 1. But nowadays we are trying to in most of the vehicles are coming in level 1 to level 4 categories in India. So there we have a lane assist system, emergency braking system, and blind spot detection system, and all these things. And the fully autonomous vehicle, the level 4 or level 5, are not much in Indian market because these things are working in testing. These things are in testing phase, and even we all know the Indian traffic condition is slightly hectic. I mean, slightly different than the other countries' traffic conditions. So these things are being in testing models, and now we are preparing some proper database for these kind of uh, these kind of systems to make it work properly in India. And the radar plus camera fusion are also utilizing in multiple companies, as well as the lidar adaptation are it's limited to research and smart cities. But nowadays, we are also using lidar in high-end cars. For example, in some expensive cars which is produced in India. For example, the Hyundai and some more assembled cars in India. So we are also utilizing lidars in that. So the adaptation is it need to be good in upcoming what is that um, upcoming days, because due to the cost of the market, we are not utilizing the radar properly. If the costs are getting low in upcoming scenarios, we may utilize LiDAR properly, and it's and then I mean the full-fledged features of LiDAR in upcoming Indian automobile markets and all these things. And the AI models must adapt to the Indian roads conditions and all these things. Like as I said previously, because we may have multiple things. Obviously, we'll be having the cows as well as the rickshaw, and we'll be giving some hand signals while crossing the roads or else something. So the AI models as well as the AI database need to be trained properly to the Indian scenarios and all these things. Okay, so these things are going on Indian market and the technology status. And the next thing is I've seen these two cars. So this is from Toyota, and this is from the Suzuki, which is the most famous car, Suzuki Swift. So these two are spotted testing in Indian roads. So these two adapt. I mean, these two are implemented with ADAS feature. Here you can see we are having the 360-degree lidar camera here as well as in the rear side. So and you can see in the sideways. So by these things we are testing the roads and we are mapping the roads according to the road conditions. So these are some test vehicles of the Toyota and other companies. And here you can see the Suzuki Swift is being tested in Indian roads. Here they have ADAS. Here you can see the lidar which is used in the grill. So and they have multiple cameras, the 360-degree cameras and the infused camera and the rear view mirror. So by these, I've I've seen some vehicles which is being tested in India. Obviously, yeah, I'm being in Chennai. I've seen multiple Mahindra cars like the 90 as well as the new Scorpio which is going to get launched, as well as the what is that, the facelifted Bolero which is going to get launched. I've spotted these vehicles on Indian roads, and these things are having some slight ADAS add-ons in their facelifts and all these things. And the next thing is Indian companies and their case studies. So if I'm talking about the Indian companies, so the first thing which is coming in my mind is Mahindra, because the Mahindra XUV 700 is the first Indian domestic car which is fully packed with ADAS. I mean the fully packed ADAS SUV which is launched in India, the first domestic car. Okay, so these what is that? XUV 700 is having multiple features here. We may have seen in multiple reviews and all these things. So these cars is having lane assist system as well as adaptive cruise control, as well as the traffic jam assist, emergency braking system, and multiple things. And as I said previous, the Mobile Eye is the proper is the company who is who is providing multiple components, and these vehicle is powered by their Mobile Eye IQ system, which is integrated in this XUV 700 car. So they are the company who are providing the components and parts and multiple things to the Mahindra. Mahindra is replacing their what is that? Their technologies to their cars. I mean, the XUV 700, and now they are going to launch the new model, which is the 3XO next gen. So there they are also implementing the next gen ADAS, where they are adding some more features in their level 3 ADAS systems. And this is how the Indian companies are working here. So they are achieved 5-star rating in global NCAP as well as in Bharat NCAP and all these things. So they're saying like they became one of the safest car in India, like the safest SUV manufacturers in India. Okay, so based on these kind of ADAS systems, they are improving their safety features and all these things. And they're also having some local ADAS, I mean, radar manufacturing companies in local area, where the HL, KL and the Mahindra collaborated each other, and they are integrating their India's first ADAS radar manufacturing facilities in Chennai. They are going to start in upcoming days in what is that in upcoming future days. They are going to start a manufacturing plant in Chennai. So based on that, they'll implement in-house radar production as well as they can able to implement in their vehicles. So the cost may be the overall market cost may get lower compared to the current cost and all these things. So these are the industries are working together, and there are few more industries in India who are working with multiple things. So I think that's good. It seems so fine. So next thing is the rule makers and standard in India. So the first thing is Ministry of Road Transport and Highways Department. So they provide the vehicle safety policies and ADAS regulations and all these things. As the ADAS is being in, it is not full-fledged in India. It is still in the construction part. So these MORTH are giving some regulations and their safety features, policies, and according to the road conditions. And based on that, the automotive manufacturers are working according to it, and the ARAI. So we obviously know the Automotive Research Association of India. So here uh, they test and they certificate their components for the ADAS and all these things, as well as the ICAT, where where they can able to test their homologation and validation systems and all these things. And BIS, obviously we know. So these things will fix their standards for their frequencies as well as the camera calibration systems, as well as they can able to certify the Indian products and all these things. And the Bharat NCAP. So the Bharat NCAP will be ensuring the safety rating according to the cars based on their features and all these things. So these are the rule makers and standards in India, and based on their thing, the automotive manufacturers will work much closer. And the next thing is the market insight in future of India. So currently we are using radar and camera fusion dominates the Indian market. The mid-range cars like the Mahindra, MG Hector, the Tata, and as well as the Hyundai are already offering ADAS, and they are also utilizing the cameras as well as the radar in their vehicles. And their AI database are being localized. Like we are making some own custom AI database in our India, but still we have to work much closer to the uh, uncongested road conditions and all these things. And in some midterm, like in upcoming 5 to 10 years, we may have some fleet autonomy for the delivery vehicles, and some robo taxis may work in control zones, because in some colleges they are replacing some autonomous vehicles and some what is that delivery systems, and what is that some robo autonomous taxis in their college campus and all these things. And multiple companies are utilizing in their implant for transporting goods from one place to another place. So maybe these things may come in on road on upcoming days, I mean upcoming years. And some smart city projects with the lidar mapping are being planned, because not only in cars, we are also having some other features in drones. For example, we are using drones for agriculture the same way we can also use the drones as well as the lidar integrated cars in roads to map the whole area. So based on that, we may have some lidar mapping data, and based on these lidar mapping, we can also have some like kind of we can have some much precise database to work according to it. Like how we have Google Map data and the Street View data now. Like that, we may also have some lidar mapping data in future days. So based on that, the autonomous vehicles make it slightly easier to work according to that. And in some long term, like more than 10 plus years, the sensor fusion may get implemented according to the add-on with the AI features and we may have some level 4 in controlled environments, as well as some higher end I mean, higher end atmosphere conditions and all these things. And the lidar adaptation may depends upon the cost drop on all these things. Like if the lidar is reduced in cost, we may adapt to the lidar more, and we can also have multiple lidar sensors in our vehicles. By that, we can get some precise data in upcoming days and all these things. And the Qualcomm Auto Day, in the Qualcomm Auto Day event on 2025, they are pushing the Snapdragon Ride ADAS platform in India. So they are trying to push it in the Indian market. So we may also utilize these what is that, the Qualcomm's the systems and all these things to make the autonomous vehicle slightly more good in upcoming scenarios. Okay. So finally, I'll come to the conclusion. Like in conclusion, in my opinion, the camera, and radar are most good in their fields. For example, the lidar is good in accuracy as well as, but the thing is, it's slightly expensive in India according to the cost, and limited R&D and premium imports and all this thing. Like due to the, I mean, these are the main reason for the cost and all these things. And camera is more affordable, and it can able to get some proper schematic images, but slightly struggles in bad weather conditions. And the radar. So the radar are more reliable in Indian weather conditions and the backbone of ADAS growth in India. According to me, in India, if we have the three sensors, major sensors of radar and camera fusion will be more good in market. But if we also add some lidar concept in this, we can get some uh, much precise data, and the data accuracy will be much good compared to the current thing, and we can have some safer mobility in futures. So that's my conclusion and uh, my final words about this topic. In future, we may have some sensor fusion. The sensor fusion is nothing but by getting multiple data with multiple sensors, we are going to combine all these data, and we are going to have some AI tuned based on the Indian conditions and all these things. So based on these, we can able to uh, make the future mobility safer and proper conditions. Okay, so this is what my final quote is. And so if you guys have any doubts or anything related to it, you can ask me. So this was my final thing, and and it would be good if I get some feedbacks from your sides and all these things. Any doubts, guys, about this thing? Hello, am I audible? Hello.
Yes, you are audible, sir.
Okay. So is there any doubt, any doubts, or anything need to be asked here, like related to the concepts or something?
Sir, my name is Binu Worki from Kottayam in Kerala.
Yes, sir.
And I find that some of the articles regarding spatial computing and quantum computing coming into ADAS.
Yes, sir.
Is it true?
Yes, sir. Because we are playing with a huge number of data here. Because even if you're having multiple cameras uh, in our vehicles, these data which is coming out of the cameras are huge compared to the other sensors. So to control and to process these kind of data, we need to have some higher end computing system in our onboard. I mean, higher end onboard computing system on our vehicles. So there they are planning to use the quantum computers as well as the higher end computers, higher end controllers to manage the data and process the data according to that. Because if you're using the lidar as well as the radar, like these two components, so these things are lesser in data. Like even though if you are getting in real time, we are not going to utilize it for the long term. We are not going to store it for the long term. These things will occur lesser data, I mean data consumption and all these things. But the camera is consuming more data. Like it is generating more data. I mean the data sizes are bigger. To handle these bigger data, we need to have some what is that? Some high-end computers and good processing computers to process the data in much closer to the real-time scenarios. Because uh, if the latency is there, if there is any latency, we may have some safety issues there. So to improve the latency, like to reduce the latency, we are using these kind of higher-end controlling systems in upcoming vehicles. So these things are going and testing models because the quantum computers or else the higher-end computers are slightly expensive to the current market. So these things are under bench model, and they may bring it in upcoming market according to the cost and all these things.
Now, the other one key area that needs to be addressed by the whole industry is that you give a vehicle at the workshop for a repair,
Okay.
and if it is hacked at the workshop point, how do you stop it?
Obviously, the Intel is working much closer in this specific category. So, like for example, the Google Waymo, it is powered by the Intel. So they are getting around 400 G, 4000 GB of data per day. Like they are getting multiple data, like based on the camera images and all these things. And as well as they are also having some uh, higher end safety protocols. For example, they are encrypted properly, where they can able to leak. I mean, where the data can't able to get out from the systems and all these things. So these things are specifically handled by some specialist team to handle this thing because it's still in construction. So in upcoming days only we will be getting the issues. What are the things that may they we may face in future conditions, but still we have some good data encryption systems in vehicles where the data can't able to get outside as well as we can able to manipulate the data accordingly. But still some misuses are happening based on the physical damages or physical changes in the sensors and modules. So it can be prevented in future conditions based on the uh, um, based on the scenarios because we need to explore multiple hidden areas in autonomous platforms and all these things. So it can be addressed in future conditions because in India just now we are entered into ADAS level 3 and 4. So still there are more way to go in fully autonomous vehicle in India. So in those conditions we have to work according to the data encryption models and all these things. So I hope these things will be addressed in future conditions. And some Indian makers are also working closely in this data encryption part, as well as Intel is also working in this category. And now the Qualcomm is coming into the autonomous vehicle domain. So they will also work with their high-end computers as well as some uh, some good in data encryption and all these things. Is there any other doubts, sir? Anything? I think Nickel is asking question like, sir, in autonomous vehicle can you use all the three at the same time? Yes, you can use all the three at the same time. That's called sensor fusion. So in sensor fusion, we can able to not only these three sensors. If we have much more sensors or some database, we can collaborate all these things together and we can work according to that. Like that's called sensor fusion. By using these multiple sensors, we can able to get some more data about the surroundings. So based on those data, we can work much closer and precise. And we can also use multiple sensors at the same real-time scenarios. Is there any doubts? Anything? But which is more efficient, all three or any other combination? According to the cost, and my thing is the leader and camera combo will be much good because they are utilizing in multiple fields. Not only in, as I said, not only in autonomous vehicles, we are also utilizing these lidar and camera combination in mobile phones as well as in drones and multiple sectors. So I personally hope that these lidar and uh, camera combination will be good in market. But still, if you use radar combination, it will be much good in data collection and all these things. Currently in the market, the radar and camera are working closer, but lidar is not much developed in what is it, the market because of its cost and all these things. But if you have lidar and camera combination along with the radar, it can be good, or else the lidar and camera combination will be good according to my perspective. Any other questions? Yeah, thank you.
Hello.
Yes.
Yeah, thank you so much for the session, sir. It was really enriching session for the participants.
Yes, sure. Thank you so much. Thank you so much. Thanks a lot. Thanks a lot for giving the opportunity
Thank you
to
all for
explain the
joining with us.
concept. Yep.